In this experiment, I wanted to find a way to identify the poles of an unmarked permanent magnet. I thought it best to use a compass to do that. But since I couldn't find mine, I decided to try and make one by magnetizing a needle and floating it in water. That way I would be sure that I have something to test an unmarked magnet against. These neodymium magnets are exceptionally strong, and I decided to use them to magnetize the needle. The poles of these disc-shaped magnets are located on their top and bottom faces. You have to be very careful not to hurt yourself when working with these magnets, since they can easily pinch your fingers. I have marked the one end with a T for top and the other end B for bottom. I kept the T end at the top and the B at the bottom when I put the stack upright on the bench. The disc magnets in the stack are sticking together, which means that the magnets next to each other are attracting each other. That tells us that opposite magnetic poles are situated next to each other in the stack. Let's assume for the moment that the poles are as indicated. If that is the case, then the other faces must have these poles on their opposite faces. Note that both disc magnets then have the same poles at their top and bottom faces. Now the top face of the third magnet down will have to be a south pole in order for the second and third magnets to stick together. Its bottom face will then be a north pole. All the other magnets in the stack will thus have their south pole on the top face and the north pole on the bottom face. We thus see that the top and bottom of the stack will have opposite poles at its ends, as is to be expected from a permanent rod-shaped magnet.